The DC voltage we use here in Saudi Arabia is 125 volts DC. I think this is normal for everyone. I mean, very nice. Okay, now let's come to the DC. Of course, I agreed with you that the main DC-DP outputs two MCCBs. One MCCB is from one section and the other is from another section. And they enter into two incomers between them. But the section is named after a small distribution board located in the 115 building, from which I take a set of miniature circuit breakers to distribute to my loads. So as you can see, I exit with a miniature circuit breaker and distribute here, a miniature circuit breaker, distribute here, one here, one here. I have a lot of circuits. I will focus on one of them now, which we will explain, God willing, today, and we will go into a bit more detail, which is the circuit breaker, motor, spring charging circuit. This is the motor that charges the spring of the circuit. The circuit breaker, exactly. So here it's called the circuit breaker motor control circuit. This comes specifically from the sub panel because of what? To supply power to my motor in order to effectively and efficiently operate. So I have DC coming from the reliable DC source, such as a DC cell or a DC board or even a DC panel of building 115. And finally, here I come to the terminal block. And from the terminal block, I enter the MCD. Pay attention here. I told you that you don't need to memorize what X1, X2, and X3 are for. It's written next to it as XD. Just like in the AC, it was written as X9. Here, X9 is used in AC circuits, while XD is used in all DC circuits. It's called XD. All right, great. Now, I want XDD here. As soon as it arrives, you must enter through the terminal block at the beginning to measure from it and then exit to the MCB. Any control circuit like the AC must start with a circuit breaker. The circuit breaker in its schematic diagram must always be labeled in the open position. What should it be? It should be open. All right, great. All right, I entered the MCB, which is someone asking? No, okay. F1 and what? F51. I entered the MCB F51. Great. Then I exit and oh, I remember you explained to us yesterday about the arrows and something is written above the arrows exactly. This arrow is made to show that it's going to another place, labeled with plus 125 volts, minus 125 volts. It wants to tell you that this is the positive terminal, this is terminal A, and this is the new terminal N. Great, amazing. So now I know that I came here to the terminal block, went to the MCB, and then exited again. It tells you this is the positive terminal, this is the negative terminal related to what? Related to the MCB, which is F51. All right, so where is it going? It tells you it's going to page 93. The positive and negative are going to page 9A3. All right. All right, which page am I currently on? I'm currently on page 8, which means it's on the very next page. Here's page 9. Page 9 is exactly related to the motor driver circuit. We said page 9D8, right? 9D3 and E3. I come here. Now, I hold page 9 like this, and here's my D, here's the D. All right? Here it is, and here you have the what. All right? Okay, regarding 1, above you have 2, 3, so you'll find where's the 3. Sorry, here it is. Where's the 3 here? It's right here, all right? In the intersection between them, where will you find it? In this area. All right, here's the 3. And of course, you'll find that the drawing isn't exactly accurate, but you'll find the what is here. Here it is. So the extremity is coming to you on D3 and the end is coming to you on what? On E3. All right. Once you know your ends, that it's talking about where are they coming from. And even if you don't know, you'll find it written on it. It's coming to you as plus 125 and minus 125 from the MCB, which is F51, coming from where? From M, from 8D5 and 8D6, meaning if you go to page number, where is it coming to you from? From M, from 8, D5 and 8, D6, meaning if you go to page number 8, here is 8, and you come here, D like this, you go D and A, D5 here and D, and also what? 6. Of course, this is wrong. So this is written incorrectly. It should be D5 and D6. This is wrong because you have your two main ends here. These two are present in 4 and 5, not 5 and 6, meaning one of them is here in column number 4, and the other is in column number 5. So, of course, this is a flaw by the engineer who was working there because he didn't correct it. But regardless, it doesn't make much difference. We encounter these things a lot, especially in busy work environments, and sometimes people don't pay attention. Excuse me, I am very sorry to forget. All right, let's get into the positive and the negative. Let's focus together on the circle. What's in our circle here? Okay, very good. So what's the idea you have now? Here is the positive and here is the negative, or the positive and the negative. If I take the positive here like this and bring it down in this way here, and the negative comes here like this, all right. Normally, I need this K14 or this contact to be closed and pass through like this, so that it eventually reaches the motor responsible for charging my spring. So the goal now is that this entire circuit is responsible for for organizing the work of this K14, so that when it closes, what will happen is the DC will reach the motor below, and your motor will turn and start charging your spring. Is the information clear like this? Okay, let's see how we will do this. I will take the positive like this, enter with it, and here's the negative like this. Of course, I have the positive here, and here's the positive, and here's the negative. Okay, let's see what our circuit here consists of. All right? Great. What does your circuit tell you? Where is K14? It tells you, well, K14, or the contact drawn in front of you, this is a contact, all right, located on page 9F7. 9F7 is the page I'm on, and F7, you will look up, here's F, you go like this and search above for where 7 is. Well, here's 7, this column, so you will find 9F7, here it is. Who is this? This is your contactor, all right? Your contactor is drawn here with its contacts, and its coil is found on the same page. This is its coil, which is what? 1 and what? B and what? 2. I want to activate this coil. So when this coil is activated, it will close its contacts here, thus supplying power to your motor. All right? Rule number 1, all miniature circuit breakers are drawn in the open position. All auxiliary relays or contactors depicted in the drawing are all in a drop-off state, meaning they are not active. All right? Is that clear? Why? Because the supply is coming from the MCB, and the MCB is naturally in the open position. So it is drawn in the diagram as if it has no supply at all. The K14 coil, WOM, is now depicted, or its contacts are drawn as normally open. When? When this coil is de-energized, and its current state in the drawing is de-energized. Great, excellent. Now, if I want to energize it, what should I do? Well, let's go. Step by step. I'll start from the top here. Here's the positive. Follow along with me, and I'll come down here like this. All right, and as I come down here, I'll immediately find something called S14. What does S14 tell you? First, S means switch, selector switch, which has more than one position, like 1, 2, 3, and so on. This selector switch has 2 positions, either lock or use. So what does lock mean and what does use mean? He said to you, by God, let's see together. You have your motor now. Why are there 2 switches? Why 2 lock and power positions? Okay, 1 and 2. What is drawn in front of me now? Bishwan, is it lock or power position? He said to you, by God, is it biased? You see, this is S14. This is S13. Here's S14 below. The first, second, third, and fourth are drawn like this, as you see. 1 and 2 change their position if you use it, meaning it locks if you use it, and 3 and 4 are closed if you lock it. So now it's originally drawn in the lock position. When you switch it to the use position, 1 and 2 lock, and 3 and 4 open. Great, very nice. So here, the words lock and use mean what? You might be doing maintenance on your motor or circuit breaker, and you don't want it to operate. You might lock the breaker or do anything, so you want the motor not to run. You will charge manually, fixing something in the mechanism or repairing something in the spring. So you don't want the motor to operate. So here, you immediately set it to the lock position. The lock position means you've disconnected the DC circuit from reaching terminal 14. This means you've completely disconnected the circuit. You might say you're disconnecting the electrical parts, but don't disconnect them. The MCB, don't disconnect it. Here, it provides you with something called look and use. Do you want to operate the motor or not? If you select look, you are inhibiting the electrical control circuit and will operate manually. If you select use, then your contact will close. Okay, you selected use. Proceed with the positive connection. Continue here like this. Of course, this contactor's coil is connected to the negative. What's missing? The positive. The positive comes down here from above, continues here, and enters a box here. This box is a dash box, dash line, and is drawn inside a square in black. Right? So where is this coming from? It's coming from the mechanism box. Who does this mechanism box belong to? It belongs to the circuit breaker A611. How did you know? Well, here I can't just say I know. No, here, engineer, you need to go back to your single line diagram. There's your circuit breaker named A611 simple. Or you will come back here and go to your circuit breaker. Here is the part of the circuit breaker, and you will find what? 611. So whether from here or from there, whatever it is, you immediately know from your single line diagram that the breaker number is what? 611. So this mechanism box is what? It belongs to the circuit breaker itself, which is what? 600 and what? 611. All right, let's proceed. Like this, go down like this. I did a lock, a user, and the positivity left. Everyone has a LS3, LS-cam, and LS1 perfect scam. Wallace is 1. All right? Nice. Who are these LS3 and LS1? If you later work in any type of factory, you will open its drawing and actually expect who these are. One of them is for manual operation, and the other means the spring is charged. You will expect, but if I explain to you now, you will open any factory and eventually find that it has two switches. One of them carries the status that the spring is charged, and the other carries the status that the spring is not charged, and the other carries the status that you are working in manual operation or charging manually. Great, okay, I don't know who LS3 and LS4 are. It will take you to page 24. All right, on 24, what do you have for 3 and 4? Cross-reference 3 and 4. I go to page 24, to the last page I have. All right, I go to the last page, I go to the last page. I have, all right, I go to the last page. I went to the last page. A3 and A4, I will proceed like this. Here are A3 and A4, meaning I will come here and find this is the motor spring operation mechanism of the circuit breaker. Inside, I will find LS3, LS1, and LS2 were written. Okay, it said LS3. What does that mean? It means the switch roll, a door with a limit switch. So this is the limit switch of the door. Whose door? It said this switch is on when the manual box cover is open. So here, when you want to charge manually, there is a cover, a door. You open this door to attach your handle and start to manually charge your spring. As soon as you open this door, this limit switch LS3, what will happen to it? It will open or change its position. It will be on, meaning it will change its position regardless of whether this switch is normally open or normally closed. So as soon as you open the door, this limit switch will change its position. This cover box is for manual operation so that you can manually charge your spring. Your spring manually? Okay, LS1 or 2 that were labeled KKL2 are the same thing, meaning it's also a limit switch, but it turns on when the spring is charging. It changes its position when the spring is charged. All right, let's go back here to my drawing. If anyone has any questions, feel free to ask. All right, we're back here. Now let's look at LS3 and LS1. LS3 will be on, meaning it will activate as soon as Osam, the cover of your box opens. This means that it is currently drawn as closed, indicating that the cover is closed and you don't have any issues, just regular electric work. LS1 will be on if the spring is charged, which means it is currently drawn as normally closed. When the spring is not charged, discharged, then this is your rule. The first rule is that everything drawn in the drawing is depicted in this position. The first rule regarding the spring is that it is drawn in the drawing. It doesn't mean it was actually discharged. I'm talking here as a drawing, reflected or drawn to mirror reality as if your spring is in an uncharged state. That's why this limit switch is closed. So if you set the use position, chose selectors, and then set the use position, then came here and closed the box or the cover box for the manual charging of the spring, in addition to the spring being uncharged or discharged, this contact will also be closed. It will pass the positive. Like this, pass the positive, like this, and find two things here, leave them. It goes down and finds K14 in front of it, with negative below and positive above, negative below on the coil of the auxiliary. What happens is that this coil gets energized. So what happens immediately is that it closes its contact, closes this contact, and closes that contact. So this one closes, and this one, what happens is that it closes. So again, you have the positive passing through here from above. You have set the fuse, so this one closes, allowing the positive to pass here. You have closed your cover box or box cover to ensure you don't operate manually or insert your handle. This means you are not working manually or do not intend to work manually. As soon as you open the box, it is not possible. It allows the motor to turn. Why? Because if you insert the handle like before, one of the young men was testing it and he inserted the handle. What happened? He pressed the motor and the motor started running. The handle jumped out, and thank God, if it hadn't been in the right position, it could have hit his hand or injured his finger. So it's completely wrong. That's why as soon as you open the door, the electrical movement of the motor must stop, allowing only mechanical movement. Exactly. Then it goes down here. If the spring is not charged, the positive will also pass through here, reaching the positive here. On the other side, which is the negative, you'll find the negative coming from here, down like this, passing through and reaching here, the cam for K14. Here it is, K14. What's happening with K14? K14 is activated. So what happens is you'll find the positive going down like this. This contact closes. Let's draw it in another color to make it clearer for us. You have the positive going down like this. And here's the negative. The negative also goes down here like this. As soon as this contact closes, and that contact closes, now you have the positive continuing like this to the motor. And the negative also continues like this to the motor. So the motor starts working and charges your spring. Once the spring is charged, what happens? As soon as your spring is charged, this contact, which is related to the status of the spring, will change its position. We said it will change its state when the spring is charged, not here. So as soon as the spring is charged, this opens. So what happens when this opens? It disconnects the DC from here, so the DC will no longer continue at 14. Consequently, this contact opens, and this opens, and thus the DC is removed from your motor. And that's it. The matter is settled. If everything goes smoothly, everything is going very well. Now, let's take a look at some of the things we might encounter. What are they? Let's say that indeed the motor, yes, we started and I did it. And here you have your switch closed. And here, no problem, it went up to here. So 14 is closed and this is closed. And here you have the connection to the motor. Here you have F20. Who is F20? This is not an MCB. You might say, but it says FA. However, if you look at its symbol and search for it, you'll understand that this is called an overload. This overload is present here in series in your circuit. So in the case that this motor is in a mechanical stack for your spring, at that time, the motor struggles or draws a higher current because it tries to charge the spring since it is blocked. So what will happen is it will draw a high current. Here, this part is like bimetal strips. You know those bimetal strips that are, if any of you have studied control or have definitely seen them in many sensors, where you have two different materials with different coefficients of thermal expansion. Therefore, when the current passes through, they expand. So when they expand, they might separate from each other completely, or they might expand upwards, and they start to do this, and they begin to push the system or push a cam. What does it mean to have a cam? It means it might be facing something like this. For example, its symbol might be designed like this. So it could be facing something like a rod, and this rod has a set of contacts mounted on it. So when this expands, it pushes what? It pushes your rod, which changes the positions of the contacts. Open becomes close, and close becomes open, and so on. So here, this is an overload as protection for your motor against it drawing or running high current due to a problem in the mechanism while it is rotating the spring or charging your spring. In this case, the F20 sees the contact line. Its arrangement is a bit like this. In this case, if it detects an overload, what does it do? It opens this contact, changes the contact position, and closes the contact. What is this contact? These are two contacts, and when it sends them to you, they are like dashed lines, indicating that the two are connected to each other by the same system or the same components. If any of you work with control circuits and PLCs, you will understand that the overload always comes with terminals 95, 96, which are normally closed, and 97, 98, which are normally open. They are now drawn with one normally closed and one normally open. The overload is depicted in a state where everything is healthy. If there is an overload, the normally closed will open and the normally open will open as well. And the normally closed contacts will open and the normally open contacts will close. All right? Good. So if this opens, it will activate K14. And if this closes, it will activate K15. Oh, sorry. If this closes, it will cut off the supply to K14 like this. Once it opens, all right, the supply will only remain here from above, meaning the supply reaches this point only. And this opens, so it cuts off the supply here. As soon as the supply is cut, it disconnects the DC from the motor as protection for whom? As protection for the motor. You might say, well, what happens when the load decreases? This overload, no, this overload is usually a hand reset or manual reset. So you have to go to the overload itself and do what? You reset it. Otherwise, this contact will remain open permanently, cutting off the power to K14. So why? Did you use it to activate K15? Because I use K15 as an auxiliary lay multiplication, meaning multiplication. Meltbla, what it means melted. The word multiplication means, let me explain it to you better. Multiplication, guys, means what? It means that now, for example, this overload, here you have only one contact normally open, which is numbered 97 and 98. Now, let's assume you want to use this normally open contact, let's say overload. You want to use it to give you an alarm in the annunciator and an alarm in the PCU. And you want to use it to send, for example, to SCADA. You want to do many things with it, but you only have one contact. What will you do? We do something called contact multiplication. Multiplication, which means multiplying, exactly. Contact multiplication means you want to make copies of it. So what do? Engineers, I go and get an auxiliary relay. I get this auxiliary relay with an order number, say, for example, 4 normally open contacts. So what happens is that I bring a positive supply and connect it to this contact. Where is the resolution? It's relaxed like this. I bring the positive supply to this contact and take its other terminal and connect it here to the coil of the auxiliary relay. And the other terminal you have here is the negative. So what happens is that when this contact operates, it changes its position. If this contact changes its position, who does it activate? It activates the auxiliary relay. So as soon as the auxiliary relay operates, it closes this, and closes this. So when this one closes, 4 close, meaning I have generated 4, what? 4 copies from it. Is that correct? So in this case, our auxiliary relay is used as something called what? Contact multiplication. And this is the second use of the auxiliary relay that we've seen now, apart from the AC supervision that we saw in our AC circuit. All right, guys, great. So now it's telling you that with the action you did when you activated K15, you'll find yourself, look down here, there's K15. K15 is used in 1, 2, 3, 4 normally open contacts and 1, 2, 3, 4 normally closed contacts. In this normally open and that normally open, both are used in circuits. One of them you'll find in the annunciator and the other in the PCO. This is an input in the annunciator and an input in the PCO. So he had only one contact in the overload and wanted to make more copies of it, so he used the auxiliary contact to make more copies, all right.